Some time ago I received from a viewer a whole box full of very useful tools. And in that box of very useful tools there was also this roughing cutter. And I would like to play with it. And what's nice, I even have an arbor for it. All I have to do is to take a spacer ring, put it on here, and then I can install the cutter itself. And I made a special little washer for it, and I have a bolt to hold these things here together. It's just that to prevent the thing from spinning on the shaft, it needs a little key. And I already made one, and as you can see, it doesn't fit. So I have to make a new one, but better. My first idea was to just make the little key and put it in and start playing with my brand new roughing cutter. But then I thought, how do you hold these very small parts in your machine? That could be a challenge. And then I had a plan. The key I have to make has a total length of 12 millimeters. On the top side, this is the side that goes in the cutter, a width of 4 millimeters, and the side that goes in the shaft, in the holder, 3.8, and the height somewhere between 4.5 and 5 millimeters. So I had to figure out an idea to hold this part, to machine it. I started from the idea that out of small material you cannot make big parts. But if you have big material, you can make small parts. So I took this piece, now it's not a big piece, but compared to what I have to make, I'm sure it's big enough. And this piece will hold my part here in place while machining. So first of all, of course, maybe put it in the vise. The basic idea is of course that my part now is hidden in here somewhere. All I have to do is to get it free. And to get it as precise as possible, I will do it all in one setup. So no opening vise, change positions, no. One setup, complete part. I just cleaned up the top surface of my future part here. And that is of course only to have it parallel with the machine. That's all. Right, now let's do this side that you can see, but I will bring you the other side. For the moment, what I did on my future part is cut this surface on the underside, because of course I drawed my part upside down. But I'm sure you'll get the point. And I cut this recess here this one at 3 millimeters. The reason why my other little key here didn't fit, I cut it at 2.5 and it got stuck in the slot. And the depth I used is of course 0.1 of a millimeter. So until now, no measurements, nothing, just cut straight, clean up, that's all. Let's start the other side. "22" to go. Four millimeter and 1/100. I'll take it. Next on the to-do list is of course cut out this little shoulder here, this little recess on the other side of the part. Let's do. Recess of 1/10 of a millimeter. Depth 3 millimeter. 2.5, 3. Let's do this. Yes. To cut my future key to length of 12 millimeter, I installed a cute little 4 millimeter end mill. And because I have a lot of material, I'm gonna make 2 keys. So I have one that I can drop on the floor, never to be seen again. To prevent false measuring mistakes, things here, I will first deburr a little bit this top surface. Because the little saw blade I'm gonna use is a 1 millimeter thickness, I don't set a 0, but I set a -1. And then we move the blade, of course. Go to 0. And now I cut off a thickness of nothing. 2.5, 5 millimeter. But I will make it a little bit smaller. Let's say 4.7. Right. I have almost no experience with this kind of cutting, singing things. So let's see what happens. I installed my machine at the slowest speed, which gives a cutting speed of about 30 meters a minute. I think it's a bit too much, but you've got to do what you've got to do. And a slow feed. It worked, and after a little bit deburring, here they are. Test. Not really easy. Cold fingers, small parts. This side seemed to fit. Haha! Success! And no wiggle. Perfect. Try the other one. Yes. That could work. To deburr my tiny little keys here, I had them installed in the vise of the shaper, and then with this primitive kind of tool very carefully took off the burrs. And then I thought, is it possible to make these parts on the shaper? Imagine you don't have a milling machine and you have to make very small little keys for whatever. Let's find out. I will use, of course, the same piece of material and also more or less the same system, which means trying to do as much as possible operations in one setup. And to do so, I will use this cute little round nose tool. So all I have to do is to switch it from one side to another, and there will be a cutting edge on all sides. The top surface is now finished and I deburred it very carefully, so that's good. Now I want to work this side, and to do so, of course, the tool needs to clear the workpiece. So we set the clapper in the direction of the cut. Tool, always look at the cut. I'm a bit afraid you will have to learn to live without footage of the making of this surface here. I installed the camera, but I forgot to press record. So the top side and this side is now finished, except of course this shoulder. Now, because I use a round nose tool, this shoulder will not be 90 degrees, it will be rounded with a radius of more or less 4 millimeters, but it will work. The trick is now of course to set the 0. Because my tool is round, I cannot use this surface as a 0. But my tool will touch with this side. So now here I can set a 0 on the height, but because I have to touch off on this side, I will take this tool away and put it here. This should be more or less the idea. So touch on the corner and then I can measure my 3 millimeter depth here. It's a bit more complicated. It's of course much easier to do if I use, for example, a straight tool. This is my tool, right? Of course the angle here is less than 90 degrees to create clearance, but I suppose you already noticed, yeah? If we touch off on this surface, use for example the cigarette paper, set the 0, move the tool back and then dial in our 3 millimeter. It's very easy, but easy we don't do, we use a round tool. So touch off on this corner here and go for it. This side is now finished, shoulder and all. Let's concentrate on this side. I have to give my tool a little bit more angle because this corner here is gonna touch the top surface. That's not good, but it will be an easy fix. That will work. "52 to go." You witnessed only one cut, but in reality I did it in 2 cuts, because I want to avoid that this part will bend under the cutting pressure. So 2 light cuts, and let's see where we're at here. Ooh, that's a big mistake. 2/100ths of a millimeter below. And here almost 1/100ths. But okay, I can live with it. 2/100ths, nothing at all. Right, let's cut this little step here but of course on this side. All operations to bring this thing to width are finished, which means that normally now this thing should fit on here in an angle, but fit anyway, and it does. The other side. This side is a little bit more tight, but we will make it work. That's good. To cut my little keys here, because I'm making two, to cut them to length, of course, in this setup on the shaper here, it's not possible because I have to cut that way and the shaper doesn't. So what I did, I measured here, put a little mark, and now I use a very small triangular file, make a little notch, and this little notch will prevent my other primitive tool here from jumping around. To cut off my three little pieces here, yes, three, because there's two keys and one piece of waste, I will use a parting tool that I of course have to put in this extended tool holder to clear the top of the vise here. So this could work. And then put in here, of course. But I'm not gonna do it this way, because if I do so, I have to lock the clapper. Otherwise my tool will lift and crash in the top side of the groove I'm gonna make. That's not a good idea. So I have to lock the clapper, what I don't like to do, because when it's really tight, what we need, it opens up these two sides here and it gives a little bend, and after some time my clapper has some play in here. So I think that's not a good idea. It's a good way to go if your clapper is more solid, more robust than this one, but here, you know. Also what happens is that the tool will drag in the workpiece on the backstroke. So I would like to use the clapper but free, and the only way to do so is to put the tool slide here at 90 degrees. So if now I put my tool in here, and of course my cut-off thing that way, bring it all up, that could work, and now the thing is free to clap. Of course, with the machine set up in this way, I cannot dial in my 4.7 millimeters using the dials. But if I install my tool at the same height as the surface of my part here, and I do this of course by raising the table, something like this. Now my tool, the top side of the tool, is at the same height than this top surface. So now all I have to do is install an indicator and bring the table up 4.7. Success! These two are the milling machine little keys. And these two are the shaper little keys. But do they fit? Let's find out. First maybe the spacer ring and then the small side downstairs. It is a snug fit. Maybe a bit too much. And this thing cuts. Right, let's try the other one. This one is a snug fit too, but much better. It's in there. The little key that didn't fit very well, I gave it a little touch of 400 grit sandpaper. And now it works and it's even installed. Now the problem is, of course, I have one arbor and 5 keys for it. What do you want to do with 5 keys for one arbor? But whatever. Let's give this thing a try. I installed my machine in horizontal mode because of the vertical spindle. You know, the bearings are a little bit cut. So I think this will be more rigid. I dialed in 0.5 millimeter, not too much to start with, and a slow feed. I run this thing at 300 RPM. Let's turn this piece of scrap in even more scrap. The machine doesn't even feel it. Let's give it a bit more feed. I think that works great. I'm gonna dial in 1 millimeter, and when it comes here, of course, it will be 1.5. This thing works great, and of course it leaves this liney finish as expected. That's nice. 5 keys for 1 arbor, but the cutter works perfectly fine. So I think it's a success.